Hello, my name is Josh Slusher, and today I will be speaking to you about the problem with plastics and a possible solution. Most of us are aware of the problems that our world faces right now, from global warming, greenhouse gases, and the amount of trash that we create on a daily basis. I'm sure that some or many of you have even heard of the Great Pacific Garbage Patch, but if you haven't, I'm here today to tell you a little bit about it, as well as a possible solution to keep it from growing in the future. The name, the Great Pacific Garbage Patch, has led many to believe that this area is a large and continuous patch of easily visible marine debris items such as bottles and other litter, akin to a literal island of trash that should be visible with satellite or aerial photographs. This is not the case. While higher concentrations of litter items can be found in this area, much of the debris is actually small pieces of floating plastic that are not immediately evident to the naked eye. Ocean debris is continuously mixed by wind and wave action and widely dispersed both over huge surface areas and throughout the top portion of the water column. It's possible to sail through the garbage patch areas in the Pacific and see very little or no debris on the water's surface. It is also difficult to estimate the size of these patches because the borders and content constantly change with ocean currents and winds. Regardless of the exact size, mass, and location of the garbage patch, man-made debris does not belong in our oceans and waterways and must be addressed. Debris found in any region of the ocean can easily be ingested by marine species, which could cause choking, starvation, and other impairments. Here you will find all kinds of trash, but it's mostly comprised of plastics that don't break down. This brings me to my main topic of plastics and why we need to do something about them. Right now, most plastics are derived from natural organic materials such as cellulose, coal, natural gas, salt, and of course crude oil. The problem with our current plastic is that it does not break down naturally. It will break up and eventually become smaller and smaller, but it does not go away. So what can we do to help save our environment from these plastics? Right now, a lot of people are looking into alternatives to plastic, to traditional plastic, and one of those companies is well on its way to creating an entirely new plastic. This company is called Newlight Technologies, and they are making plastic out of air carbon. While reading an article on the increase in methane emissions from dairy farming, Mark Hurama, a student at Princeton University, had an idea. What about using greenhouse gases as a resource like plants do every day? What if the carbon already in the air were recovered to make plastic? After all, what is plastic made of but carbon atoms? After 10 years of research, childhood friends Mark Herrera and his partner Kenton Kimmel founded Newlight Technologies in California in 2003. And they think they have found the solution to replacing the standard plastic with a new material called air carbon, manufactured from methane using innovative, less expensive, more environmentally friendly production processes. They decided to create plastic from recovered carbon that is already present in our air. This not only helps eliminate some of the harmful greenhouse gases, but also creates a biodegradable product that will not harm the planet. The first step is capturing the methane emissions, which is a short-lived greenhouse gas that has a more potent warming potential than CO2. They collect this from dairy farms, water treatment plants, landfills, and energy facilities. Inside a reactor, the gas is combined with air and converted to a liquid polymer before being made into plastic pellets. According to its inventors, the peculiarity of the reactor developed by Newlight is its efficiency. Its yield ratio is apparently 9 times higher than other reactors. This fundamentally shifts the cost structure of the greenhouse gas plastic to conversion process, meaning air carbon can outcompete oil-based plastics such as polypropylene and polyethylene on price. Although some scientists remain skeptical, is the process economically viable? Does air carbon really keep the carbon negative promise? And if so, isn't it just a drop in the ocean? Newlight has accumulated awards and contracts. They currently have contracts with Sprint for smartphone holes, Dell for packaging on some of their laptops, and furniture manufacturers for their collection of chairs. As of 2021, Air Carbon has now ventured into making a multitude of products from foodware to fashion. They have created reusable plastic-free regenerative foodware, starting with drinking straws and cutlery. These items have a carbon-negative footprint, they're dishwasher safe, reusable, along with having the added benefit of never getting soggy in hot or cold drinks. If the utensils do not get used and thrown away, they will break down and natural organisms consume them like they would a leaf or a twig. They also make items such as sunglasses, handbags, wallets and phone cases, and a product called Air Carbon Leather, which all share the same biodegradable properties. Similar initiatives are popping up all over the world, like the unique prototype operating between 2011 and 2013 in the Aquarius treatment plant in Brussels to demonstrate the feasibility of recycling sewage sludge into biodegradable plastic for use in industry, turning pollution into a resource. Some of the other products that they have created are the Air Carbon straws, the cutlery, and this is what also makes Air Carbon products great. Air Carbon products have no synthetic plastics or glues. They're strong and reusable. They're good for hot and cold food and drinks. They're home compostable, industrial compostable, ocean friendly, and regenerative carbon negative. Again, my name is Josh Slusher, and I hope that you learned something new and enjoyed my talk. Thank you all again, and have a great day.